shape? Okay. Parallelogram. If you go back to chapter 6, way back in January, that's the start of the semester, we defined a parallelogram as a quad where both pairs of opposite sides are parallel and congruent. Any of the four sides is considered its base. So this is here the base of a parallelogram is any of its sides. You could say the bottom is the base, you could say the left side is the base, or the right side. Doesn't matter, any of the four. The corresponding altitude is the segment that's perpendicular to that base. Back in chapter 5, we practiced drawing the altitudes of triangles. An altitude is defined as starting at a vertex, going to the opposite side to make a right angle. The length of the altitude is called the height. So altitude and height represent the same segment. The name of the segment is called an altitude. The length of it is its height. What you need to remember is that the base and height will always be perpendicular to each other. So the base and the height will always make what type of an angle? A 90-degree angle. You have two examples, and I have put 4 up here on the smartboard of what the base and height might look like on parallelograms. So this first one, the same one that you have, I chose the base to be the bottom, then my height, my altitude is perpendicular to that. So it's going from the vertex to the opposite side. The second one you don't have, I use the top side of the parallelogram as the base. So from a vertex on the bottom, to go to the opposite side and make a right angle, I get this altitude. The third one you have, the left side I chose as the base. And then I'm going from the top right vertex to that side to draw an altitude. It's on the outside, but that's okay. If you go back to chapter 5, sometimes the altitude of the triangle was on the outside. If I take that altitude and slide it down to the other vertex, is it going to change in length? No. Will it stay perpendicular to the base? Yeah. So your altitude or your height, when it's on the inside, you can also slide it out, and it's still the length of the segment, still the same segment. So sometimes your altitudes jump out. Same as this third one here. My base is on the bottom. If I use this right vertex and draw straight down, there's my altitude. I can slide this along, and it's not changing in length, and it's staying perpendicular to the base. Okay, so you just need to make sure you look for the two segments that make a right angle. That's your base and your height. Because to find the area of a parallelogram, it's just like a rectangle. Run like 2/3 of the way down your paper. Area of a parallelogram, base times height. Area of a rectangle, base times height. You need to know both of these. Well, it's the same formula, but you have to understand that it works in a parallelogram and a rectangle. Okay. Doesn't matter what type of polygon it is, your base and height will always be perpendicular to each other. So to the bottom. Let's find the area of each of these parallelograms. If you're a flashcard person, maybe you want to start making flashcards for the area formulas today. So you're going to keep adding to them all chapter. Another way that students do it to remember, every time they see the parallel or the polygon, put the formula behind that word. So area of a parallelogram is base times height. You're going to have a lot of worksheets this chapter, so you'll be able to write them on the worksheets behind each word. Base and height have to make a right angle. For the parallelogram, any of the 4 sides could be the base. I've given you the left side and the bottom side. Gavin, which one should we use as the base? Why? Good. The bottom makes a right angle with my altitude of 8 over there. So I want to use the bottom side as my base. So area of a parallelogram, base times height, 12 times 8 would be 96. I don't know if it's centimeters, inches, feet, so put units squared. If I don't give you the dimensions, then put units squared. The middle one, let's find the area of the parallelogram, base times height. The base can be any of the four sides. I think Brad, which side should we use as the base?
16.
Why?
Because it's perpendicular to 8.
Good. 16 is perpendicular to 8, my altitude. So then our area, base times height, 16 times 8, 128, right? Units squared. Third one. We have a side length of 22 and a side length of 28. Jackson, which one should I use as my base?
The 28
Why?
because it forms a right angle with the altitude.
Good. It's perpendicular to my altitude. Morgan, do you know the length of our altitude? How'd you get that? Oh, you use your SOHCAHTOA. Alright. That'd be my height. I don't know it, but we create a right triangle here. So if I go back to yesterday's test, opposite of 30, hypotenuse, SOHCAHTOA says the sine of 30 equals h over 22, right? That's what you have written down. Nicole, how would you punch this in the calculator?
22 times 30.
What'd you get when you did that?
11.
Good. Is there another way you could find the value, Grant?
Yeah, so the altitude's across from 30, so it's the short leg, and you take the hypotenuse, cut it in half, and that's how you do your short leg.
Awesome. This is also a 30, 60, 90 right triangle, one of our specials. So then this is my short leg. This is still the hypotenuse. So you used this yesterday too. Hypotenuse equals short leg times 2. 22 equals h times 2. So that would also tell you that h is 11. You could use either. Total area though, you have to take 28 times 11 plus 280 plus 28. 308?
Yeah.
308 units squared. One thing about that. My worksheet that I give you today is going to say I want the exact area. So just be careful when you use SOHCAHTOA. If that doesn't come out as a perfect number, then you're going to have to jump to your special rules or your Pythagorean theorem. Does that make sense, Morgan? Okay. Good on the front side? Cool. If you haven't been listening, I hope you listen now because you'll have a question like this next one on your assignment today. And some of you will probably leave it blank because you won't know what to do. It says a parallelogram has 9-inch and 18-inch sides. The height corresponding to the 9-inch base is 15 inches. We want to find the height corresponding to the 18-inch base. Okay? If I flip back here quick, 18 and 16 make a right angle, right? Okay, if I draw in my altitude, isn't quite right. From here to here, this guy and 10 kind of make a right angle, right? So if the area of this parallelogram is 128, what would this blue height have to be if its base is 10? Try to find the area of a parallelogram. Base times height. This base is 10, and its corresponding height is h, right? So if I take 10 times h, shouldn't I get 128? Right? It's the area. So when I divide by 10, this height would have to be what?
12.8.
Thank you, 12.8. Every parallelogram has 2 bases and 2 heights. Okay, so on this next question, you're going to have to try and find that missing height, the one they don't give you. So start by drawing a picture of a parallelogram somewhere in that space, either above or below the words there. And it says it has 9-inch sides and 18-inch sides. The height corresponding to the 9-inch base is 15 inches. So that means the side that's perpendicular with 9, or the height, is 15 inches. So if I start at this bottom vertex and I draw in my altitude to the other side, this guy is 15 inches. It says it corresponds with it. It means those two sides make a right angle. Find the height that corresponds to the 18-inch side. So we're trying to find the one that makes a perpendicular with the 18-inch side. So if I start at this top left vertex and drop my perpendicular down there, I'm trying to find that height. You may want to make note of this, it's not on there. First, find the area of the parallelogram. That's the first thing you want to do. Riley, how do you find the area of a parallelogram again? Good. And Gavin, the base and the height have to make a what? Good. I have two bases, 9 inches and 18 inches, since I have two sides. And I have two heights, h and 15. Which one should I use if I want to calculate the area, h or 15? 15, right? Because it's a known value. So 15 is perpendicular with the 9-inch side or the 18-inch side? 9-inch side. So according to this formula, area equals base times height, then I should be able to say the area of this is 9 times 15. Do you agree? Mm-hmm. And that would give me an area of 135. Okay. Area is the number of squares that fit inside of this polygon. I have another height, h. Who is h perpendicular with? 18. So using this formula, area equals base times height, shouldn't I be able to say the area equals 18 times h then? You with me so far? Okay. Did the number of squares that fit inside the parallelogram change when I picked the other base and height? Okay, so if the area is 135, can't we use algebra and substitute 135 in for a there? And say 135 equals 18 times h? Divide by 18. I don't remember what that is. 7.5. Then our other height is 7.5 inches. First, you find the area of the parallelogram with the base and height you know, and then you divide by the other base. That's your shortcut. Find the area of the parallelogram using the base and height that you know, and then divide by the other base. Okay, there will be one like that on today's worksheet, and you'll see some on next week's worksheets too. Okay, put a star next to it. I don't know why, but those ones students struggle with a lot. Cool. To triangles. Remember way back in chapter 3 and 4 and 5 and 7, triangles are a three-sided polygon. We have different types of triangles. We have equilateral ones, isosceles, scalene. It doesn't matter what type of triangle it is. To find its area, it's 1/2 base times height. Hopefully that sounds familiar to you because you were doing it last chapter in chapter 8 and you've done it before in your school career. The base can be any of its sides, and then the height has to be perpendicular to that. Or the altitude does. So just like your rectangles and parallelograms in a triangle, the base and height will always be perpendicular. They always have to make a right angle. Let's try the first one. Find the area of triangle XYZ. Area of a triangle. 1/2 base times height. You guys doing presentations in there today? You don't have your break? Okay, keep clapping. I think they just applaud Mrs. E. Bright when she gets like done doing something. Okay. Be cool if my students would applaud me like that. Base, any of the three sides. I've given you two, 31 and 30. Which one should we use as the base? Why? Good. 30 is the one where the altitude is perpendicular to. So I I know then that we're going to take 1/2 30 times 13. Well, 30 times 13 would be 390. And then you take half of 390. 195. Go for your label. Okay, try the second one. Find the area of triangle XYZ in that picture. Area of a triangle is 1/2 base times height. The base can be any of the three sides. And we're looking at the big guy, X, Y, Z, so I can either use 24 or 20. Which one would have to be my base? Why? Yeah. 20 is the one that the altitude is perpendicular to. So I know then that my base is going to have to be 20. We don't have the length of our altitude or height. We have to find it. What can I use to find my height? Good, Brooke. I have to use the Pythagorean theorem. If I call this point where the altitude drops down W, YW is 4 centimeters. YZ is 20 centimeters, so how long is WZ? 16 centimeters. And then I have this right triangle here. So using the Pythagorean theorem, because I know no angle measures, a leg squared, h, plus a leg squared, 16, has to equal the hypotenuse squared. 16 squared, 256. 24 is 576. So if I subtract that over, I get 320. Square root that. Does it come out nicely? Okay, don't round it. We're going to leave these in exact form. I know that 16 would go in there 20 times. Square root of 16? 4. Can I break 20 down? What perfect square goes into 20? 4. How many times? 5. Square root of 4. So now we got 4 times 2 times the square root of 5, and 4 times 2 would be? Alright. So the height is 8 square root of 5. So then I go over here and put it in my height part of my formula. Don't be dependent on your calculators. What's half of 20? What's 10 times 8? So then our area would be 80 square root 5 centimeters squared. Again, this is the exact area because it's in radical form. And that's how most of your assignments will be this chapter. I want them in exact, unless it's noted otherwise. Okay? So that means either Pythagorean theorem or special right triangle rules. Try not to use SOHCAHTOA unless it doesn't say exactly. Go ahead and try that third one. Triangle ABC is a right triangle, so the two legs will be your base and height. So AB here is going to be my height since it's vertical. Using your Pythagorean theorem, hopefully you got that length to be 5. So then the area of your triangle, 1/2 base times height. Again, don't be dependent. What's half of 12? And 6 times 5 is 30. So then the area of this triangle would be 30 square centimeters. If I gave you a piece of paper and I said cut out 30 squares that are a centimeter by a centimeter and paste them on there, they would fit in there nicely. You might have to cut some of them in half to get your corners there, but you would be able to get them all in there. Questions on triangles? Okay, we have one more to do. The bottom one on the next page. This is an ACT type question. The front of a garage is a square 15 feet on each side with a triangular roof above the square. The height of the triangular roof is 10.6 feet. To the nearest hundred, how much force is exerted by an 80-mile-an-hour wind blowing directly against the front of the garage? Use the formula. F equals 4,000 AV squared, where F is the force in pounds, A is the area of the surface in square feet, and V is the velocity of wind in miles per hour. So we're going to see what it feels like if the wind is blowing at 80 miles an hour, how much that is in pounds coming against this garage. We're trying to find F, the force, so I don't really need to worry about that. But we have to figure out the A and the V. What's the A stand for again? The area of our surface that the wind's blowing on. And in our case, it's the garage. And it says here the front of the garage is a square with a triangular roof. So in order to calculate the area of my whole garage, what are we going to have to do? Yeah, find the area of the two separate shapes and then do what with them? Add them together. Alright, so we have to find the area of the square and the area of the triangle and then add them together. Haley, how do you find the area of a square? Good. Haley, what's the base length of my square? How about its height of my square? Good. So then we'd get an area of 225. Triangle. Cole, how do you find the area of a triangle?
Base and height and then half of that.
Good. On my triangular roof, Cole, what's the base?
Base?
Yeah.
15.
And its height?
And
79.5.
Sure.
304.5. Can you add them together? Okay. I know you guys can't see because I'm totally blocking your view right now, aren't I, sir? That's the area of the garage. Okay, so that would be our A part. V says it's the velocity in miles per hour of the wind. Do we have to calculate that, or do they give it to us? It's 80 miles an hour. They give us that right here. So we know our V. So we're going to take the 304.5 and the 80 and put them into that force formula that they supply for us. Give us F equals 4,000 times 304.5 times 80 squared. It's just the 80 that gets squared. It's just the V that had the little square there, the superscript 2. So then you got to throw that in your calculator. Just be careful, watch your parentheses and such. Maybe do it one thing at a time. Or go backwards. Do 80 squared and then multiply it times the other numbers. Read carefully. To the nearest hundred. Hundred, not hundredth. So there's no decimals. Our number should end with 2 zeros. So that third one is your hundredths spot. So what do we come up with for the nearest hundred? 7,800? Pounds. So, with 80-mile-an-hour winds, it's like 7,800 pounds of force against this garage. That'd be about how many tons? Almost was 4 tons, right? Those are like hurricane type ones. Isn't that interesting? Okay.
Go lower right there.
Yeah. Was it really that tough of a question? No, not really, right? So when I say ACT, it's not too scary. You just had to remember square and area and triangle areas, right? Otherwise, everything else they gave us. Okay, you good? Cool. Oh, escape.